Hi class, this is Bill Berry with a continuing video in our Course Orientation and Intro to Programming series. In the first video we talked about the basics that you needed to know about programming languages and compilation versus interpretation, and we got some of the basic stuff covered then. The second video we did our first script, and I showed you what to do the basic HTML and script commands that you needed to write a very simple script. So we got ready for that, and then in this video we're continuing on and learning a little bit more specific stuff about JavaScript and kind of perhaps wrapping up our introductory lecture series. And we'll see if we need one more video, but perhaps this one will be sufficient. So let's see how we do. The slide that we're going to jump to today, let's see, we're going to getting to know JavaScript, right? So what is JavaScript? How does it relate to other languages, etc.? So the first thing we want to do is put the knowledge that we already learned to sort of in context here. So JavaScript is an interpreted scripting language. That means that it is not a compiled language. You don't need a compiler. It doesn't create an executable that runs on the machine. Instead, you need an environment to run in, and that environment happens to be a browser. The browser will interpret your code and then run it in the browser. So it is interpreted. It is a good way to interact with HTML and CSS. So if you know a little bit of HTML and a little bit about how styling works in the web environment, then JavaScript can interact with those things to control web page behavior and content. And it also has access to something called the DOM, the Document Object Model. And the DOM will give you a lot of access to objects that you can manipulate, and we're going to learn how to work with some of those. So that'll be very convenient. One thing to notice is it is a case-sensitive language. So lowercase student isn't the same as uppercase student. So let's look at an example of that, because it's kind of important to know the difference. Notice here we have a lowercase s, and here we have an uppercase s. Now one of the things that is a little bit interesting for us, let me switch to the desktop and we'll take a quick look. One of the things that's interesting to us is that we are working in both JavaScript and in HTML, and there are slightly different rules for casing there. So let's pay attention to that and look at some examples. Here we're in HTML clearly. So here if we happen to case something strangely, it's going to work okay because HTML is not case sensitive. But the thing I want you to pay attention to is once you're in here, once you are inside this script block, you should be very careful about casing. So the command, for instance, document.write, notice we do all in uppercase or in lowercase. If I change it to an uppercase W, it's not going to work properly. So you do need to make sure that you are careful about all of the things that you type inside the script block to make sure that those things are cased exactly properly. Now, one of the things you'll see is in text literals like this is a literal, we can type this any way we like because this is literally the text that we want to show. So if I put hello in uppercase letters here, that's just going to mean that hello is going to show in uppercase letters wherever it shows up. So we don't worry about it as much inside quotes. I know that's a little bit confusing at the start, but basically HTML, case it the way you want. I recommend lowercase. Inside the script, case appropriately for whatever the command requires. We'll study more about that. And then when you are inside quotation marks, as we're going to study later, do whatever you want because that's how the thing is going to show up. So that's just a little bit about what you'll see there. Also notice that it is a loosely typed language. That's also going to mean that we don't worry so much about data types as we might in other places. That means that, for instance, when you're working, let me get my window back properly here. There we go. When you are working, you don't necessarily tell JavaScript as much about the data types. For instance, in Java, you're always telling it very specifically, hey, this thing is going to be an integer, this thing is going to be a string or text, this thing is going to be a floating point number. We don't spend so much time talking about that in JavaScript because it is loosely typed. So we can kind of put whatever we want wherever we want, and for the most part that kind of works out okay. So it seems a lot less rigorous than a language like Java or C, where you have to be specific about types. Also note it is going to be mostly a client-side programming environment. So typically this is used when somebody's running, a client means on their computer on the end user side, you're going to be running JavaScript there. It's going to be embedded in a script run on the client, on the browser, on the client's computer. There are some cases where you can use it on the server side. There still may be reasons to do that, but mostly we see it as a client-side opportunity. Also do note that it's called ECMAScript, so if you hear that, it is the same thing as JavaScript and it is a standard, and down here you'll see a link to the official publication documentation, so you can go find out more if you're interested in what that all means. So that's just a little bit about framing JavaScript in terms of what kind of language it is. Now, what is it not? What are things that we should know about JavaScript that it doesn't do? Well, first of all, even though it has the name Java in it, it's not really particularly related to Java. They did borrow some syntax and some concepts from it, but it really isn't related. It doesn't come from the same code, the same sources. It's not really related to Java. But it certainly, JavaScript borrowed some ideas from Java. It borrowed some ideas from some other places. So it's it's related only in its name and only in some of the borrowed syntax. Also, it is not an all-purpose language. You can't use it for every single thing that you might want to do. So, for instance, you can't read and write from the disk. So you might say, well, I want to write a little JavaScript program or script that will read some data from a file and do something interesting with it. Well, no, you won't, because it doesn't read and write from the disk. It also doesn't make network connections. These are security things, and they decided you don't want to have something that's living in a browser that can so easily be transported and live in a browser window in HTML that can do these things, because this would just not be safe. So you can't do those operations. One other note, it doesn't work in all browsers the same way. So if you want to make sure that your JavaScript is going to work in all scenarios, you actually have some work to do. Most of the stuff we write should work perfectly in all the modern browsers, but if you really want it to be completely workable in all kinds of browsers of all ages, you'd have some extra work to do. The other thing is you can see slight differences. So if you run on, let's say, Firefox and Chrome, you might see something maybe tiny bit different, but certainly when you run an Internet Explorer, you might see something different. So if you're really writing interesting JavaScripts, you might want to check in a couple of browsers to make sure that you really are getting the behavior that you think you are in all those cases. So that's a little bit about what JavaScript is and isn't. The next thing we're going to do is learn about a little bit more about the internals of the language. So we're actually getting into the programming and what can you type where. So this is something that goes into our scripts. The first thing to know is there are things called literals. And literals are values that you can type in, and you don't have to explain them or give any context to JavaScript. It's just going to understand them. So if you were to type the number 4, for instance, it understands that 4 means 4. You don't have to say anything else about it. It understands that that's the number 4. Or if you use a number with a decimal, 8.6, it says, okay, that's 8.6. Everybody knows that that's a number. So when you type numbers, just type the number. You don't put anything around them or do anything special. You just type the number. However, if you're typing strings or text and you want those strings to be treated exactly as they are there, you want them to mean exactly and show exactly what you want them to do, what you want them to say, you put them in either double quotes or single quotes, whichever you find most convenient. As you might guess from seeing that, if you had a single quote in the string, you might want to use the double quotes around the outside and vice versa, with the apostrophes, and then you could have a double quote inside and that would be okay. So you need to put strings, literal strings that you want to express exactly that way, in double quotes. That's more standard, so I would use the double quotes by habit. The other thing is there are things called booleans. Booleans say true and false. You won't see this used a lot. We'll touch on booleans here and there, and they're important, but we won't use them as much as we'll use these other two things in our beginning course. So that gives you a little bit of information about what you can type and how JavaScript is going to interpret them. Now, if we were to go back over to our script, you could see that in here in the document.write in our first script we typed hello there world. We put quotes around it because that's a literal piece of text. But if we wanted to do something slightly different, for instance, if I wanted to put a number, I could put 600 and blah 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 point, and I could put some decimals. So if I were to save that and run it, it's going to work just fine. Let me launch that in Firefox so you see, and Firefox will show that number just exactly there, just like you saw it before. So there's no problem with that. It'll work exactly as you expect. So those are some literals that you need to know about when you're typing in JavaScript. Next one is, well, there's some little sidebars here. I'll probably talk about these in class, but I'll leave them here for pause the video if you want to read them a little more specifically. The next thing we want to talk about is operations. So JavaScript has very typical operators, and you can use these to do math. And typical operators include plus, minus. Multiplication is using the star. Again, that's very typical. Excel will do the same thing in most programming languages. Division is a slash. Notice that's the / by your right pinky down by the shift key on the right. And then there's also a remainder operator. Now this one's kind of funky and different, but it is very useful in certain cases. And what it says is take the remainder. This is also called modulo. It says not divide 23 by 4, but it says if you were to take 23 and divide by 4, how many would be left over after an even number of divisions, an even number came out. So 23 divided by 4, if you started doing longhand division, you would say, oh, 5, that's going to go in 5 times. 4 goes into 23 5 times with 3 left over. So the modulo or remainder gives you that difference, which is 3. That's the leftover portion. Again, can be very handy. You can also raise things to powers by putting 2 asterisks right together. Don't put any space in between them. So 2 raised to the 3rd power. So if we look at these examples, 5.2 plus 4.1 shouldn't be much of a surprise what that's going to be, right? 6.3. Subtraction, same thing. You know what that's going to be. Multiplication, again, fairly straightforward. That shouldn't be any mystery. How about division? What about 5 divided by 2? Well, this is going to do floating point division. So 5 divided by 2 is 2.5. Remainder, we already talked about. That should give us 3 remainder from that operation, and the power 2 raised to the 3rd power should be 8. So here's all the results. Those should all be exactly what you'd expect. Shouldn't be any surprises there with the way that JavaScript does typical kinds of math. One more thing, we're not getting too deep, but just one more about strings. We do want to know that there's a special operator that is also a plus. It looks like the mathematical plus, but if any of the operands are strings, then plus is going to mean to concatenate rather than to do addition. So particularly if the first operand is a string, then it's going to know to make this thing a string as it goes along. Now JavaScript is going to try to do some funky things, so there are times when you might have something that looks like a number in quotes, and JavaScript will try to convert it and do something clever. So yeah, there's other kind of cleverness that JavaScript's going to do. But in this case, if we put a plus, that's going to say, hey, this is a string. It knows this is going to be concatenation, and it's going to take Joe and Schmo and stick them right together and come up with a new string that has Joe Schmo. Now notice there is no space added automatically. So if you want the space to be there, you have to add it. How could you do that? You put a space between the E and the quote, or you put a space between the quote and the S, and certainly that would work. Or you could concatenate another thing that said quote space quote, and then concatenate that in the mix, and that would also work. You can also use this with numbers and strings together. So if you started out with the answer is, and then you said plus 7, this is not going to do math because this is a string, and it's not going to be turned into a number, so it's going to take it as a string, and it's going to say, oh, you must want to concatenate, not add, so I'm going to just smush on the 7. I'm going to coerce the 7 from a number into a string, and I'm just going to stick it on there. So that would turn into a string that says the answer is 7. So we're going to find various times that it's nice to be able to concatenate things to just create a longer piece of text from individual pieces, and that's what concatenation can let us do. Now, another set of operators that we want to look at are called comparison operators. When you need to compare two things, which we'll do in a couple of chapters, I'm giving you the full list here, even though we're not going to investigate these really deeply right now. When you want to compare two things, usually we think of doing this with numbers, not always, but usually, you can use the following operators to do comparisons. The first is to test for equality, you use two equal signs together. Now, I know this is a little bit strange to your eye because there's going to be two things we use equals for, but this is one to note right away. When you want to compare equality, you must use two equal signs. If you want to check whether something is not equal to something else, you use an exclamation point and then an equal sign. And by the way, all of these are kind of typical operators. You'll see these in other programming languages, including C and including Java. Now, other typical ones, greater than or equal to, less than or equal to, all very typical. Just remember, the ones that take two symbols, you must put them right together. Do not put a space between the two symbols or it will not work. You'll get some kind of weird error. So you do need to keep that in mind. Now, what is the answer to each one of these things? Is 5 equal to 4? Well, the answer certainly is going to be false. Is 5 not equal to 4? That is true. 5 is not equal to 4. Is 5 greater than 5? Nope, 5 is not greater than 5. But is 5 greater than or equal to 5? Yep, sure is. Is 4 less than 5? Sure is. Is 4 greater than or equal to 5? Nope, it is not. That is false. So just keeping these in mind, and we'll come back to them later when we need them a little bit more, and that'll be in a couple of lessons. We'll come to those. All right, and last set I do believe, last set I do believe is going to be logical operators, and this will be a while, but we'll come back to these as well about the same time. If you need to check whether two things are both true, you can use the AND operator, and that uses two ampersands right together. The OR operator puts two vertical bars right together. The vertical bar tends to be above your Enter key, and you'll see that there on your keyboard. So and then you also have one called NOT, and that is going to be just an exclamation point by itself, and that just turns the logic on its head. If the thing was true before, it'll turn it to false, and if it was false before, it'll turn it to true. And you can use these things to make various more complex conditions. So for instance, is 4 less than or equal to 5? Yes. Is 3 less than 1? Nope, it's not. So this part's true, this part's false, and since one of them is false, the whole thing cannot be true since it has AND. So a true thing ANDed with a false thing, the answer is going to be false. Here, is 4 less than or equal to 5? Yes. Is 3 less than 1? No, it's not. But since this is an OR, if either one of these things is true, this is going to be true. So you have to think about, what does and what does or mean? Again, we'll come back to these and spend a lot more time. Same thing here. 4 is less than or equal to 5. That is true, but if we put the exclamation point in front of it, that will turn it into false. That inverts the logic. So those are some logical operators. Again, just remember these for reference. Keep these slides around, and when we get to it, you'll have a reference back to to where the list was of all that. Okay, so now let's put our knowledge together here, and let's talk about expressions. So how is this going to look? What's the answer to these things? An expression is a series of values and operators that can be evaluated. You can determine a result if you look at the whole thing. So let's look at these and figure out which ones, what the results are. So what is 4 plus 5? Notice we have parentheses around things, so we don't get the normal order of operation. 4 plus 5 is going to happen first. That's 9. 9 times 6, that should be 54. Yay. Okay, what's next? Well, we have an addition here and we have a subtraction, but we know based on even our middle school math, I think, certainly high school math, that we go in order of precedence. So I learned, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. So in this case, we know that the division is going to come first. So 3 divided by 2 is 1.5. 2 plus 1.5 is 3.5. Minus 1 should be 2.5. Right? Yes. How about the next one? Well, division-y and multiplication-y things happen before addition. So it's going to take 23 modulo 5, or 23 remainder 5. So we do that first. What's 23 divided by 5? Well, it goes evenly 4 times, but we don't care about the even, right? 4 times 5 is 20, but 3 is going to be left over. So we know that that's going to be 3. We add 1 to it, and that's going to be 4. How about this one? Well, strangely, these are going to be kind of late operations, right? The comparison operators are going to happen very late after most others. So we do 2 times 3 gives 6. Is 6 greater than or equal to 6? Yes, it sure is. That is true. How about this one? Well, you can continue on and work through those if you like. That one's true, that one's false. This one, we're going to smush together a bunch of text, take the word Johnson, take a comma and a space, and smush on Chris. So of course that's going to return Chris, or Johnson, comma, space, Chris. And last but not least, answer equals 7 divided by 2. It's going to need to do the math first. 7 divided by 2 is 3.5. Then it's going to smush that onto the text via concatenation, and the result is going to be answer equals 3.5. That's going to be the text. All right. So next in the deck you're going to see a class challenge, but I'm going to skip over those, and in fact I'm going to stop the video here because it's getting a little bit long, and so we'll continue on with one more video to wrap up this topic. Shouldn't be a long one, but this has gotten us a long way to understanding and framing what JavaScript is and what some of the basic building blocks are that you need. We looked at literals, we looked at typical math operators, we looked at other kinds of operators and expressions, so that gives us a good fundamental list of things that we can work with in the language. So thanks for watching. Post your questions in the discussion forums or online if you like, and we will see you at the next video, and thanks for watching again.